Next, let's look at some more graphs. Let's graph using transformations. When we look at this function, we notice it's an exponential function because you have a 2 to the x power. Let's put some parentheses right there. So first thing you notice is that's going to move it to the right 1. You notice there's a exponential with base 2, and then you also notice that there is an vertical shift up 3. So we should be able to sketch this using transformations. We know the basic graph of 2 to the x hits the y-intercept at 0, 1, and then starts growing really fast. So I'm going to pay attention to the two features. I'm going to pay attention to the horizontal asymptote, and I'm going to pay attention to the y-intercept. So if I move the y-intercept to the right 1 and up 3, that'll bring me over to here. If I move the horizontal asymptote to the right 1 and then up 3, now it's going to bring that asymptote like so. And now it's going to be flat, 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 flat until it hits the intercept, or what used to be the intercept, and then it'll start growing fast. And that's our exponential function with a shift to the right and up 3 using transformations. Next, you might ask, great, so what happens if I change the base from base 2 to, say, base 3? Well, if we were to make a table of x and y values, 0, 1, 1, 3, 2, 9, negative 1, 1/3, negative 2, 1/9. So what kind of similarities and differences do we see here? Again, our y-intercept is 1, but now if x is 1, y is 3. If x is 2, y is 9, somewhere up there. And now the function is growing faster. So here's 3 to the x. Here is 2 to the x. So you can imagine 5 to the x or 6 to the x would be even steeper, and that's how the base changes the shape of the graph. What about a base that's a fraction, such as f of x equals 1/2 to the x power? You might be tempted to think that it looks the same as this one, but just more flat. But what I'd like to point out is this can be written as 2 to the negative 1 to the x. Now you see there's another property of exponential functions. Exponentials there. We can multiply. Now when I see this, the transformation that I see is a flip across the y-axis. So now the graph is going like this and flattening out there. So if we have the function f of x equals a to the x, if a is greater than 1, we have a shape that goes like that. If a is between 0 and 1, we have a shape that goes like that. It flips it across the y-axis. What if we have f of x equals negative 2x plus 3 minus 1. Okay, starting at the x, we work our way out. First thing we notice is we're going to move to the left 3. Then we see a negative in front of the 2, so that's going to flip over the x-axis. That is, it's going to flip it down. And then we see that minus 1, and that minus 1 brings us down 1. So here is our base 2 to the x graph. We're paying attention to where the intercept is and where the asymptote is here. And I'm going to go left 3. I'm going to flip over the x-axis and then down 1. So this point, that intercept point, left 3, flip across the x-axis, and down 1 brings us down to here. If I take the horizontal asymptote and we move it to the left 3, it's still on the x-axis. If I flip it across the x-axis, it's still on the x-axis. And then if I move it down 1, it brings me down to here. So my graph is going to be flat, 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 flat. And then once we hit that intercept point, now it starts to grow really fast. And that would be the same graph as if I had written f of x equals negative 1/2 to the x. Sorry, let's take it back. And that's the end of that problem.